Hi, we are Canary in a Coal Mine Designs, and this is our final senior project video report. My name is Avish Menon, and I am joined on this team by Zachary Riley, Nathaniel Soderberg, and Jeffrey Weiss. Our mentors for this project are Professor Hugh Barnaby, Professor James Aberley, and Partha Chakrabarty. Our project aids in building a device that can detect specific amounts of radiation in close ranges. While there are currently devices that can perform this functionality, they are either bulky and immobile or much more expensive than our device is aiming to be. There are many applications for this device, such as nuclear threat detection, scanning the inside of nuclear facilities, ensuring proper radiation doses for cancer patients, and for space weather research. Our entire system is comprised of a few different parts. First, the sawtooth wave generator feeds into the voltage-controlled oscillator, which creates a chirp signal. This chirp signal is then transmitted through an antenna, and after being reflected off the target, the return signal is received by the second antenna. This return signal is then mixed with the original chirp signal and then analyzed for peaks. Next is Nathaniel, who will talk about our progress this semester.
Hello, I'm Nathaniel Soderberg. I'm going to talk a bit about our progress that we've made for this semester. So after COVID-19 happened and stopped all of our plans for physical testing, we moved more towards getting as accurate simulation results as possible and adding a little bit more functionality to the receiving side of the device. We switched our circuit simulations from LT-SPICE to ADS, which should provide more accurate results at our higher frequency range that we're working with. We also created some system Verilog code that does a little bit of the work of interpreting the return signal. So currently it just outputs the delay and number of clock cycles between the start of the return signal and the spike in intensity that it sees due to the reflection off of the target. And further processing would have to be added to correlate that back to an actual radiation dosage in the future. But at the moment, just doing some quick math with the system Verilog simulation output, it does get very close to the frequency that we're expecting to see, as described by the description of the target. And now Jeffrey's going to talk a little bit more about our changes in plans and what we had planned before COVID-19.
Thanks, Nathaniel. So due to unprecedented events pertaining to the coronavirus that occurred in mid-March, we've had to shift the focus of our project. We had lined up a bill of material, the circuit, the Gerber file, everything necessary to have advanced circuits fabricate and assemble our printed circuit board. But due to the lack of testing facilities, we had to shift our focus of the project. The supply chain was also hindering the amount of devices that we could receive. Our voltage-controlled oscillator was unorderable, and so the shift of the project went towards programming Verilog and simulating our circuit so that we could see what type of chirp signals we would be able to produce and have data ready for future projects to take up what we had already accomplished. And now here's Zach.
Since the coronavirus interrupted our attempts at producing a physical prototype of the hardware, the biggest thing we would like to have carried through to the next group who work on this project would be to do just that. In it, the choice may be made to change out the custom VCO we designed with an off-the-shelf version in the same frequency range to reduce the complexity and potential cost, as well as the debugging time. Along with producing and testing a physical version of this hardware, there are also some tweaks that we hope we'll be able to get addressed in the Verilog code to process the return signal. One thing we never quite cracked was how to deal with the, albeit minor, delay from the signal being sent out to the signal being received, just due to the travel distance. And this will vary slightly according to the distance at which the sensor array is placed relative to the interrogator.